welcome to The Explainer. So today we are bringing some serious energy to a topic that honestly has the power to completely transform how your organization builds its products. We're getting into strategic frameworks for product and process architecture. Essentially, we're talking about the fundamental blueprint of what you're building, that's the product architecture, and the exact sequence of steps you take to build it, the process architecture. Our overarching goal today is to show you exactly how to take those frustrating, invisible bottlenecks in your development cycle and turn them into actionable, undeniable economic wins. Let's get right into it.
Here is our roadmap. We're going to start by taming hidden process cues. Then we'll look at generating information efficiently, specifically through failure. After that, we're hacking the traditional staged gate process. And finally, mastering your product architecture. This framework is going to completely shift your mindset from just traditional building to highly efficient information generation.
Okay, let's dive into Section 1, Taming Hidden Process Cues. This is where we confront the very real problem of hidden delays in the development lifecycle. Have you ever wondered why perfectly good, highly innovative product ideas just stall out? Think of process development queues exactly like a frustrating, invisible highway traffic jam. You can't always see the cars piled up, right? But you absolutely feel the delay. For instance, imagine a critical feature update that takes a developer maybe 3 days to actually code, but then it just sits in a manager's approval queue for 3 weeks. There are no literal files piled high on a desk anywhere, but that idle time is silently eating up your timeline, and more importantly, it's bleeding your budget.
To fix this traffic jam, we have to look at the actual science of waiting, which brings us to queuing theory. Now, usually this is a pretty dry mathematical study of waiting lines, but we are directly applying it here to product development. The core takeaway, like the real Blinkist level insight here, is that wait times do not increase linearly as a system gets busier. Actually, scratch that, it's worse. As your system approaches full capacity, wait times increase exponentially. By looking at these economics, queuing theory stops being a math headache and becomes a very tangible, manageable reality for your business.
And the economic cost of these delays? It's stark. When you compare optimal capacity to excessive queues, you quickly realize something huge. Pushing for 100% capacity utilization is a massive trap. If every single developer or designer on your team is booked at maximum capacity, you've got absolutely zero slack in the system. The second a minor bug or a tiny delay happens, it cascades into a massive queue and completely kills your flow. The goal isn't just to work harder. It's to set the exact right level of capacity to maintain momentum, and that capacity has to be strictly justified by the numbers. So, once you have those numbers, you've got to act on them. Evaluating options to reduce these queues is your first big step toward clearing the backlog. But what are your actual options? First off, you can actively limit WIP, work in progress, forcing teams to actually finish your current tasks before pulling in new ones. Second, drastically reduce your batch sizes. That way, you're testing and moving smaller chunks of work through the system way faster. And third, invest heavily in cross-training your teams so a bottleneck in one specific skill doesn't just halt the entire pipeline. Every single option you pick, though, has to be deeply rooted in that underlying economic justification.
Moving right along to Section 2, Generating Information Through Failure. We need to fundamentally rethink what development actually is.
Now, what's really interesting about this concept is how it aggressively challenges traditional business thinking. Fail earlier, learn faster. If we view development purely as an information generation process, we have to embrace failures. They aren't these awful, career-ending setbacks anymore. They are a vital, money-saving tool. Just think about the massive cost difference between finding a fatal product flaw during a cheap, early-stage paper prototype versus discovering that exact same flaw after you funded a massive, full-scale production run. No way you want the latter, right? Early failure tells you exactly what you need to know, exactly when it's cheapest to know it. Okay, so how do we put this into practice on, say, a random Tuesday morning? First, you formally adopt the view that development literally is information generation. Second, you actively improve your process design to make that happen. This isn't just telling people to work faster. It means implementing daily automated testing or creating much tighter feedback loops with your actual end users. And third, you use those tight loops to produce information earlier. Redesigning your process to surface that critical data right at the beginning is exactly how you prevent those massively expensive late-stage development disasters. Let's step into the blueprint phase of our explainer with Section 3, Hacking the Staged Gate. I know a lot of you are intimately familiar with the classic staged gate process. It's super common because it provides clear structure and these nice, predictable risk check-ins for management. But its rigid, purely sequential nature can completely bottleneck your flow. It often forces these massive batches of work to just sit idle, literally waiting weeks for a formal gate to open before the next team can even look at it. The staged gate is a framework meant to be critically evaluated and hacked to suit your specific needs. Definitely not a sacred text you have to blindly follow.
So the crucial point here is that you've got to proactively design your processes to mitigate those downsides. How? By changing the way shared resources are measured. Instead of rewarding managers for high individual resource utilization, basically just keeping everybody busy, you measure and reward the speed of delivery through the entire system. Next up, aggressively look for opportunities to overlap your development processes. Just imagine a hardware team saving 3 full weeks simply by sharing early, imperfect CAD models with the software team, running those 2 stages concurrently rather than strictly one after the other. It's an absolute game changer.
And that brings us to our final section, mastering your product architecture. Let's look at how the physical or digital architecture ties directly into your economics. Fitting architecture to economics usually comes down to how you partition your systems. Partitioning is basically just deciding how to break a complex product down into distinct, manageable chunks. Think of it like designing a modern car using modular platforms. If you isolate the engine architecture from the dashboard software, a glitch in the GPS doesn't require a total recall of the physical engine block. By partitioning correctly, you optimize risk management, increase your market coverage, and drastically reduce ongoing support costs. Product architecture is absolutely not just a technical exercise. It is core business strategy.
Let's see how all this builds into a cohesive strategy. Balancing economics, risk management, and leverage points is where the real magic happens. By identifying specific leverage points in your architecture, say standardizing a single power supply component across 10 different product lines, you get direct control over your risk profiles. If that power supply needs an upgrade, you engineer it once, and boom, you immediately leverage that fix across everything. It's the perfect balance of lowering long-term support costs while hitting your broader economic goals.
Which leaves us with this final, absolutely critical question to ask yourselves and your teams today. Is your product management team actually managing the architecture? Understanding product management's role in these vital decisions is the key to unlocking everything we've talked about. Remember, your processes and architecture aren't just rigid constraints. They're incredibly dynamic tools for generating information and driving massive economic value. Take this framework, challenge your current processes, and start turning those hidden bottlenecks into your biggest economic advantages. Thanks so much for joining me on this explainer. I'll catch you next time.